For more information, please visit SGMAK Associates website.
In this presentation, I'm going to discuss internal rate of return, estimation of internal rate of return for a simple cash flow. What are the limitations? And then I want to discuss a mixed cash flow problem where you compute rate of return a little differently and it offers a more logical approach. So let me walk you through an example. This is related to leasing a car and then later on buying it after the planned period. So here's the problem statement. The cost of a new car is $64,000, but it can be leased for 36 months with a monthly payment of $679. You make initial down payment of $3,500. In addition, you have additional cost, one-time payment of $1,304. Then you're paying at the end of each month $679, and at the end of 36 months you can purchase the car for $39,000. So what is the internal rate of return for this problem? So the cash flow diagram is shown here. As you can see, it's a simple cash flow with the first and if you can think about, you got a benefit of $64,000 in terms of how you look at it. It's a benefit coming to you, and then you are paying it off with initial cost and then all the annuity payment and then the remaining payment of $39,000 at the end of the planned period. So it conforms to a simple cash flow problem. So to find the internal rate of return, we set up the equation for net present value with an interest rate unknown, and then set that equal to 0 and solve for the interest rate. That gives you the IRR. So net present value equation is present value of all the benefits minus present value of all costs. So you have benefit 64,000 and then rest all our cost minus one-time payment of 4,804 minus the present value of the annuity minus the present value of a one-time future cash flow of $39,000. So that's the expression for net present value. If you set that to equal to 0, we get an approximately 1.4% per month. You can use interest rate tables. So you are paying 0.25% per month. So your nominal annual percentage rate is 12 times quarter, which is 3% per year. That's your nominal annual percentage rate. And your effective is you got 3% per quarter, the 4 compounding periods in a year. So effective annual percentage rate is 3.04%. Okay, so that's for a simple cash flow. Now let's look at a mixed cash flow problem where you have first, typically you have an inflow, that means money into the project, and then you have outflow, benefits from the project. But in this case, in a mixed cash flow problem, you have an inflow in later years also. So in this case, you can think about the inflow to the project is money that you're putting in, outflow the benefits that you're getting out. For this particular project, later on you got to support the project by putting in money into the project. So it's a 7-year plan and the cash flows are given here. They are in millions of dollars, just as a unit. Like I said before, in a simple cash flow problem, initial cash inflow is followed only by cash outflow from the project, and single discount rate is used to discount both inflow and outflow. Just one discount rate is used throughout the problem. But in reality, we know that the borrowing rate from the bank is different and typically lower than the rate you're likely to be earned from an investment, depending on how you invest. There are a whole range of options you have, and it is, you can say safely that your borrowing rate is typically lower than the rate you can earn from your investment. So what you need to do is, compared to the previous problem, we need to incorporate two different discount rates in our analysis. So one rate is, we call it finance rate, the borrowing rate, 8% we have taken for this problem, applied to borrowed funds. And investment, we have taken 15%. Well, parameters can change. We have taken a 15% that you can earn from the investment. So you got to use two rates, one for the money borrowed and one for the money invested, money that came out of the project and invested. So the approach what we'll do is as shown next. So first we compute the present value of all inflows into the project, money that. So we bring the cash flow at different points in time using a discount rate of 8% and a planned period of 7 years. So we are bringing the individual cash flow. The first money that you put in was $4 million at time 0. So you see 4. Then plus the amount by multiple corresponding factors, and all of them are P over F factors at 8% rate, because we are converting future cash flow to present value. So we're using the P over F factors. So the present value comes out to be $6.744 million. All the inflow brought to the present value, discounted at 8% rate, because that's the borrowing rate. Next, what we do, we compute the future value of all outflows from the project. All the money that we got came out of the project that we have invested. And we are computing a future value, so taking the individual cash flow to end of 7 years. And our discounting rate is 15%. That's what you assume that you got a good investment plan, and that's what we can earn. The key thing to remember, two different interest rate, and typically borrowing rate is lower than the interest you can earn on investment. So the present value each has a factor F over P in this case, because we are taking from present to future. We are taking the individual cash flow to end of 7 years. So that comes out to be future value $16.48 million. So now we are saying at what rate, for this mixed problem, at what rate a present value of $6.744 million has a future value of $16.48 at the end of 7 years. And that's our mixed internal rate of return. So what we have here in this expression, present value multiplied by 1 plus MIRR, stands for mixed internal rate of return, raised to the power 7, because our planning period is 7 years. So that single present value of $6.744 million converted into present value. That's what you should have at MIRR. That equals to 16.48. So if you equate that, we get a mixed internal rate of return of 13.6%. So the traditional IRR has a drawback, since it uses the same discount rate for both inflow and outflow, and that's a serious drawback, because typically those rates are different. And we made that correction in our mixed internal rate of return analysis. We feel that offers a more logical approach to the problem, because you got to treat those two cash flows separately, because they have different earning power, borrowing rate and investment rate. So this is an example that brings out the difference between a simple cash flow and a mixed cash flow, and how to handle them. So hopefully this is of help to you. Thank you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.